Hello everyone, this is the video lecture for Pre-Calculus section 7.4 Basic Trig Equations. And they use the word basic in a way that we wouldn't. Um, so this will be an interesting little lecture. I'm going to tell you beforehand, basically every question in this section is going to use this little phrase in their words. Let K, I'm going to try really hard for lowercase k. Come on. Well, there you go. Lowercase k, let K be any integer. You'll see that a whole lot. And as you continue through this class, when you see that, be scared because this means a very particular kind of problem, and we're going to be working on that here together. Now, I cannot draw lowercase k's very well. I'm going to continue to use capital K. So just know that I'm using capitals, but in reality, it's a lowercase. I think they probably will only take the lowercase. So what are we doing here? 74008. Here we go. I got cosine of theta is equal to a positive square root 2 over 2. And they're saying solve for theta. Now, here's the thing. Pause, pause, pause. This plus sign here is not really there. I'm just using the plus sign to indicate, hey, this is a positive. But really, they're just going to have that number, of course. I think it's important to have an understanding of the positive and negative ahead of time. That way I don't just go jumping into it, super fast. Cosine implies an x value, and it's positive. And notice the square root 2 over 2. So let's just say, like, oh, I've seen that before. It's on my unit circle. So I go to my unit circle, and I see right here my x value is square root 2 over 2, blah, blah, blah. I don't really care. And I see it one other time right down here. Again, square root 2 over 2, blah, blah, blah. I don't really care. Well, notice that, yes, this is just square root 2 over 2 as well, but I don't care. I'm looking for when the x value, the cosine, is the positive square root 2 over 2. So these two guys. Well, that would be pi over 4. Again, you could just say 45 degrees. And 7 pi over 4. Again, another way to say that would be the 315, I think. Yeah, 315. Okay, cool. Well, there's my answers, right? You put them in, and you got to use radians, apparently. Put these in, and you're wrong. What do you mean I'm wrong? So let's understand what they're meaning now when they say this. Let K be any integer. What they're trying to say is that it works for these two angles, sure, but what if I went around one full time and then an additional 45? Basically 360 plus 45, which I think is 405. Would 405 work? Yeah, 405 would work. What if I kept going? What if I went this way and I got to this one? And then I kept going again. What if I started here and went down? What if about like a negative 45 degrees? Wouldn't that work? And there are infinite answers to these. So what I'm needing to do is somehow give you an expression for all of the answers that are ever possible forever and ever. And that's where this K comes in. I'm going to give you the short answer. It's very easy. I'm going to take my answers that I found and say plus 2 pi k. Again, comma separated still. Plus 2 pi k. Again, lowercase k is not capitals. And that's it. That's how you do it. What I'm basically saying with this plus 2 pi k, I'm saying that every revolution will have these two answers. And again, if we keep going, the relative angle would be that pi over 4, that 45 degrees. But I'm just saying go around as many times as you like. It'll always be the same answer. Okay? Go around again and again and again. Go around 5 times. As long as you end up on the 45-degree line, you're good to go. As long as you end up on the 315 line, you're good to go. That's what I'm trying to say. On Webassign, I think they'll do this guy, 2k pi, if you went and got it wrong or something, just to see what they have. I can't remember. This is fine. This is good. That's the end of that problem. So that doesn't seem too bad. Well, okay. Maybe so. Maybe not. Maybe that seemed really terrible. Well, we have a lot more to go. So cosine theta is equal to 0.64. Again, I'm going to emphasize the fact that's a positive, okay? It's a positive. They even say to round to 2 decimal places. So we have that. In order to find theta, I'm going to use the arc cosine of the 0.64. Basically move the cosine over with arc cosine. And I got 50.208 degrees. Okay. Cool. Well, where's that on my unit circle? If it was on my unit circle, where would it be? It's right here, about 50.208 degrees. Cool. Oh, not squared. Okay, cool. So we got that. Notice again, this is the x value, right? We're talking the x value, and it's positive, right? It's positive. Where else is it positive? X values is down here. So just as I guess a refresher, this is on the side here for a second. What if I had an angle here at 60 degrees? The same x value is down here at a negative 60 degrees, okay? If I had an answer over here at 30 degrees, my other answer would be at negative 30 degrees. What I'm getting at is they're symmetric to one another, and so my other answer is definitely a negative 50.208 degrees. That's my other answer. What I would say is I want to, I guess, give myself like a positive value. Negatives are not good in general. It probably will still work. It probably will. But like, what should I actually do? I'm going to say the 360 minus the 50.208. And again, what is that angle? It's going to be this guy right here. Now, I didn't actually do that on my paper. I'll show you why here in a second. 208. I got 309.792, and that makes sense. That's pretty close. So those are my two angles, and so I'm going to just basically say 50.21, 2 decimals, right? Plus 2 pi k, right? Is that how it works? No. 2 pi is radians. I'm so happy that we got degrees here. Yay. But they don't want degrees, they want radians. So what would be my answer in radians? Everything else is the same. Don't think that I'm going the wrong way here. I just wanted to understand what this was. And everyone understands 50 degrees. Are you going to understand when I give you the fact that it's actually equal to 0.876298 radians? Do you know where that is? Me neither. I don't know where that is. I have no clue. So that's why we talk about degrees, so we could talk about this problem. So this is a good answer. How would I go and find my other answer? Remember that I said, 360 minus amount. So 2 pi minus this amount. And here I got the 5.406887, again, radians. So these are excellent answers. Now I'm just going to do that 2 pi k thing and call it a day. So my theta should be, again, these are decimals here, basically, 0.88, I guess, since it says 2 decimals. I still did not do that, and I still won't do that. You can do that on your own, of course. If you're more precise in Webassign, it does not penalize you. If you're less precise, then it will penalize you. So I always go extra anyways. That's supposed to be a K. Close enough. Okay, there we go. Cool. Next problem, 74013. So I have the tangent of theta is equal to -1. They say, where's that happening? Remember that this is actually a slope. Say my slope is -1. And that's going to be at a 45-degree mark. Basically negative 45 degrees. Or 315. Up here we got 135, by the way. If I were to actually use radians, though, this would be 3 pi over 4 and 7 pi over 4. So those are my two answers. And, of course, I want to go and give you the 2 pi k answers. So here we go. I'm going to say now 3 pi over 4 plus 2 pi k. Then 7 pi over 4 plus 2 pi k. Okay. Now, let me show you what Webassign actually has. This is good. If that does not work for you, if this style does not work, there is a technical problem. You need to contact me. I'm going to go off on the tech support guys or whatever, okay? This will work. This format is fine, okay? I always teach it this way. But what Webassign is going to tell you is this guy here, that's their answer. This is Webassign. And it's not bad, but let's analyze how they just compressed it down to one single answer. Apparently that's okay. Well, they said, let's start at one of these angles here. So they started here. And they said, you know what? It's not that I have to go around every time. I don't have to go fully around. Rather, what's going on is that the other answer is only a half rotation away. So not 2 pi k, but just a pi k. And another pi, and another pi, and another pi, and another pi. That's why they don't have to have 2 different answers with commas. What I'm saying, the difference between my answer and their answer, my answer is saying, okay, well, I found one of my answers. I'm going to go a full revolution, and a full revolution. And then I say, okay, whoa, but there's another answer. It's right here. And then I'm going to go a full revolution, and a full revolution. So I got basically 2 answers, thus the comma. 2 different answers, thus the comma, but they're saying, oh, you can compress it down to 1. I do not teach it this way. I don't. You can use it. I don't mind. It's easier to type, but concept-wise, it's just something additional that you'd have to see and think about, when really you could devote that to something else. Sine of theta is equal to negative square root 3 over 2. Trying to make that 3 a little bit better. There you go. So again, this is the y value. Remember that? The y value. This is negative. Okay. So like a negative y value, already I know I'm down here in quadrant 3 and 4. Just saying. But it's a big y value. So it's down here and down here. That would be at, this is definitely 300. So this is 240. Yeah. Well, they don't want degrees, obviously. So this is going to be a 4 pi over 3. This is a 5 pi over 3. Those are my 2 answers. So I say, okay, well, theta then, my answers should be 4 pi over 3 plus 2 pi k, 5 pi over 3 plus 2 pi k. Okay. And then they give you a part B. So finally, this is all good. Everything's been great. But this particular problem has a part B. And they say, list out 6 specific answers. Now, remember, first off, get a huge box. Remember that Webassign, you do not need to simplify. You do not need to simplify. And so we can use that with, maybe against them. Anyways, so 4 pi over 3 and 5 pi over 3. That's my first revolution. These are 2 specific answers, right here and right here. And I'm going to go around another loop, I guess. So 4 pi over 3 plus 2 pi. And 5 pi over 3 plus 2 pi. Again, don't add a k. This is times 1. K is 1. K is 1. Okay? So that's easy. Keep going. Let's do some more answers. So I got 4 pi over 3 plus 4 pi. 5 pi over 3 plus 4 pi. And heck, I can keep going. 6 pi, 8 pi. I wouldn't do 7. 6, 8, 10, 12, etc. Just keep on adding as much as you need. They only want 6, so there you go. You do not need to simplify. You know, if you went and got it wrong and saw what their answers are, oh yeah, they're going to simplify, and you know, this is divide by 3, so it is a 6, and 6 plus that is a 10, and then blah, 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 whatever. I don't care about that. Webassign does not care about that. 74027. Square root of 2 times the sine of theta plus 1 is equal to 0. Solve for theta. Okay, again, k for whatever, blah, blah, blah. Just the same as all the others. Well, we need to simplify this first. I'm going to move the 1 over and divide by the square root 2. So I got a negative 1 over the square root of 2. Is this on your unit circle somewhere? No, not really. But I'm going to ask you, what if I multiplied the top and bottom by square root 2 over square root 2, something like that. Notice in my numerator, I got this guy. In square root 2 times square root 2, you get a 2. So I'm saying that the sine is equal to this thing. This is my y value. And it's negative, and it's the square root 2, so square root 2 over 2. Negative y value here and here. That's going to be at the 315 and the 240, 230, 225, 225. There we go. Of course, that's going to be a 5 pi over 4 and a 7 pi over 4. These guys. And those are going to be my answers with some 2 pi k action. That's it. So notice that I simplified it. I didn't think that was very difficult. We've simplified harder things than that. Again, just simplify it, do a little bit of math here, and you can see that basically you have what you really thought the whole time. Next one, 74037. So I've got secant squared theta minus 2 equals 0. So first off, move the 2 over, right? And I want to square root both sides. Now. Remember, when you square root both sides, you need to have a plus and a minus. You need to have a plus and a minus. Now this is going to be interesting. I know that secant is 1 over cosine. I'm just rewriting that. But if I keep doing the math, I want cosine by itself, so I can understand what's going on. So I'm going to swap my cosine with the square root 2 business. And so cosine theta is equal to, like I'm flipping both sides basically, it's equal to a plus minus 1 over the square root of 2. You know what? We just saw this guy. We just saw that guy. Whenever you see that, you just know that it's square root 2 over 2. So x value, positive and negative? Like basically, as long as you're seeing a square root 2 over 2, negative or positive or anything, square root 2 over 2 in the x value, that's an answer. So over here at 45 degrees, or pi over 4. Over here at 315, 3 pi over 4. Down here, 225, 5 pi over 4. And finally down here at 315, 7 pi over 4. Those are all answers. And yet, those alone are still not enough, because we have to do the 2 pi k business. Get ready. So we got our first one plus 2 pi k, our next one plus 2 pi k, all the way out, plus 2 pi k, every single answer, plus 2 pi k. Here we go. Whew, all because of a square root. Yeah, there's harder ones. Moving on. 74041. I've got 4 sine squared minus 4 sine theta plus 1 is equal to 0. I give up. It's too hard. Oh, no, it's not too hard. So whenever I see this format, I think quadratic. What if I had it as x's instead? Now, I'm going to tell you, this guy right here, even with x's, that's still really difficult. Like here, find the factors. Is it 2 and 2? Is it 4 and 1? What do I even start with, So it is pretty tricky alone, but that's the idea, is that I want to rewrite it like this so I can get my answer this way. So I'm going to be straight with you. The best way is just to keep on just guessing, check and guess, and try out a few things. I mean, at this point, there's definitely other methods for doing this back in college algebra. If you want to follow those methods, that is okay. Do that. It's like the 4 times the 1, and then you're trying to find those factors that add up to the middle and all that kind of stuff. That's great. That's a good method. I'm not going to use that method here. Just get to this guy somehow, okay? That's your answer. We can always double check. 2 times 2 is 4. Good. -2, and another -2 make a -4. and then 2 negatives make a positive 1. Okay? So this is my factored form. Well, notice that they're basically the same thing. You're going to get the same answers twice, so I'm just going to rewrite one of the factors now. To solve for theta, I guess I could do sine of theta is equal to positive 1/2. Notice positive. So my y value is a positive 1/2. Now positive means y value is going to be over here, but it's a small y value. That half is a small value. 0.5 versus 0.866. And so I'm going to use them over here. This is going to be 30 degrees, or again, pi over 6. Over here at 150 degrees, or 5 pi over 6. Trying to remember it all. I don't have all these answers written down. Actually, I got the radians down. Yeah, okay. I guess I do have them. I just don't even look. And so, again, remember, I've said this way back in another lecture, back in like chapter 5, that unit circle, you know, have you memorized it yet? At this point in the class, have you memorized it yet? You don't have to, honestly. You don't have to. I still recommend it. Not just because you'd be super smart. You could show off at the dinner table. But it really increases the speed and understanding here as well, okay? I'm not memorizing the whole thing, just as I've said in the past. Really only memorizing quadrant 1, and then I remember positive and negative. Notice, why am I always saying if it's positive or negative? Why is that actually important to me? Why can't I just go and look whatever's going on? Well, because I know positive y values are in here in quadrant 2 and quadrant 1. I just know that because, well, I've done it so long, and when you do it so long, you kind of remember that stuff too. Okay? Moving on. So, as you know, my answers would be those two guys, the pi over 6 plus 2 pi k, and then the 5 pi over 6 plus 2 pi k. That's it. Still got more. 74050. So I got 3 tangent cubed theta equals tangent. Now this is one interesting equation. You know, I went through a lot of math classes to get to this point. Not just teaching them, but actually, like, you know, taking them. And what I would always do, just between you and me, I would say, oh, well, divide by tangent on both sides. And I'm going to say that is the worst thing to do. Don't do it. I would always get answers wrong, and I wouldn't know why. Why is the answer wrong? Don't do that. Don't do that. Don't cancel tangent right now. You're going to lose information. You're going to lose part of your answer that way. I know it sounds easy, but rather you need to move it over, and then you're going to factor, okay? I know that's like one extra step. Heck, it's 2 or 3 extra steps, but it's still the most... It definitely will always give you the right answers, okay? Canceling, just because, I do not recommend it at all. I've been down that road. I was down that road for many years myself, always getting stuff wrong, not knowing why. I'm telling you now, don't cancel. Okay. So, I got these 2 factors here, and I need to solve for theta, I guess you can say. Solve for x, kind of. Like, this is kind of like an x in a way. This one's actually pretty easy because every factor is equal to 0. Tangent theta is equal to 0. Now, this guy's going to lead us to something here in a minute. I'm just saying, cool with this guy. We'll talk to him in a minute. Let's keep going for this one. So 3 tangent squared theta minus 1 is equal to 0. Move the 1 over, divide by the 3. So I got a positive 1/3. When you square root both sides, though, oops, you get plus and minus. Square root of 1 is just a 1. Square root of 3 is this guy. And I'm wondering, like, where have I seen this before? Just leave him alone. He's okay. Actually, you know what? I'm going to do one step. I'm going to do one small step here. Tangents are not directly on your unit circle, though. Doesn't it kind of look like it might be unit circle, right? It has that square root 3. But every time you see a square root 3 in a unit circle, it's always divided by 2. If that's the case, what if I had a 1/2 and a square root 3 over 2 like this? Wouldn't the 2's cancel and I would come back to the original? Right? The 2's would cancel. But I'm setting it up like this so that you can see that this is from the unit circle, okay? This looks like unit circle material now. My tangent is going to be a y over x, right? A sine over a cosine. So I'm looking for a y value at this and an x value at that. Notice plus and minus. This is going to be some crazy answer, let me tell you. But I like this guy, so here we go. Let's start drawing circles for these. When is the slope equals 0? 0 slope right here and right here. Okay, so at 0 radians, 0 degrees, and at pi radians, 180 degrees. So those are two of my answers. Over here, I'm looking for when, that's unit circle. I'm looking for on my unit circle where I have my tangent. Well, I guess let's just not say tangent. Let's say my y value is 1/2 and my x value is this guy. X values are bigger. Notice plus and minus, anything plus and minus, as long as I got x values are bigger. So over here at 30 degrees, pi over 6. Over here, 5 pi over 6. Again, here's some negative stuff, 7 pi over 6. And finally over here, 11 pi over 6. I'm saying any variation of negative and positive, I don't really care about negative and positive as long as I'm seeing my x is this guy, my y is that guy. As long as I see those, negative or positive, I don't really care. Go ahead and list them. You can see I got a lot of different answers. So I got 2 of them over here. I got 4 of them here. Total of 6 answers. Yes, 6 answers. On top of that, not only is it 6 answers, but you still have to put the 2 pi k in there. Now, I know that they would simplify this thing down a lot. You can simplify this down to 3 answers with a plus pi k, and I'll show you that, I suppose. I do not recommend doing it. I recommend this long way. Because, yes, you're typing a lot, but you're not having to put more brain power into it. You got your answers. You're done. There's your answers. See, Webassign would say, no, you got to keep going. You got to keep going to simplify some more. And I don't want to simplify. I'm not a simplify kind of guy. Maybe you are. I don't know. So go ahead and simplify if you want. I'm gonna stop here, and I'm just gonna start typing. I'm a lot faster typing. I'm a fast typer. So that's another thing. So if you're a slow typer, but you're a fast writer, maybe you want to keep going. I don't know. So here, this is good enough for me. Good enough for Webassign. Everything that will work there. How do they get their answer? What's their answer look like? What's going on for them? Well, let me show you their answer. It's like half as long. First off, they're just going to put pi k out of the blue. They don't put 0 plus because they don't go that far. No way. Pi over 6 plus pi k and the 5 pi over 6 plus pi k. They might have even said a negative pi over 6 plus pi k. That's an equivalent right there. That's fine if they're wanting to be that way. But that's it. That's a lot shorter. So what's going on? Notice that if we start right here, oops, didn't want to zoom in. That's good enough. So if we start right here, right, and then I go half a rotation. Well, there we are. Half a rotation, half a rotation, half a rotation. So that works. That's great. What about right here, starting right here? So half a rotation, half a rotation, half. And same thing here, starting at 0, right, 0 plus, half a rotation, half, half. Just another way to do it. Again, that's nice for them. I don't do it. I don't recommend it. I'd rather type out the bigger answer but not have to think about all that kind of stuff. Maybe you're a trig professional at this point, and so you automatically think in good ways like that. I don't know. Last question of this section. So I'm trying to draw like a word problem here. It's talking about the refraction of light on water. Okay. We got an angle here, theta 1. 1 is a subscript. And they got this guy here is my theta 2. I'm just going to do a little arrow this time. Okay, cool. We have air up here, and we have water down here. So it's like water, basically, like that. And they say that the refraction ratio is 1.33. They say that theta 1 is equal to 65 degrees. And they also say that sine of theta 1 divided by sine of theta 2 is equal to V1 over V2. Now, what are they talking about? Well, this guy right here is my fraction, and we know that that's going to be a 65. So I'm just replacing a couple things here. That whole entire ratio turns into a 1.33. Don't even try to plug in individual stuff. It's already done for you. Cool. Well, then to solve for theta 2, I'm going to move this guy over, divide by over here. I got this now. To keep going, I would arc sine both sides. Move that sign over with an arc sign. Notice that I have to be in degree mode here. Now, I didn't really use my calculator yet, except for that one decimal problem. But you better be in degree mode here for sure. And I got, just plugging it straight in, I got 42.955. Those fives are really ugly. 836 degrees. There you go. And that's it. All right. Thank you very much. Have a great day.